goes down to... See, look, I messed that one up already. That was a double bond to a nitrogen. We'll show that in a minute. Okay, so we'll finish this ring up. That's the 6-membered ring there. This goes to the ribose. And the ribose goes to the phosphate. If you remember up here, we'll zoom it in a little bit for you. It says oxygens on it, right? So you got an oxygen to the sugar. You got one that's double bound. You've got one that's got a plus on it. So you got one, let's say, we'll put the negative on this one and make this one go off to the next ribose. So you got every kind of oxygen on the phosphate. Ribose, just 5-membered sugars with the greens. Do I even got that right? Probably don't. So we're going to focus off that. We're back to the DNA here. Somebody's going to call me on that nitrogen. See, I just didn't want to start thinking about that. So over here, this is a single-membered ring. Thymine. What color is thymine? We'll give that the blue. Like uracil. Thymine or uracil. So that's it for that. I mean, gosh, what do you got? A double bond there goes to a methyl. Methyl CH3. You got this to an H. Nitrogen's done. Carbons are done. So look how simple that was. Nitrogen, where's our blue? So isn't it interesting that the nitrogen's held to the ribose and the nitrogen is held by the bond here too. So the two nitrogens are being utilized in the thymine ring. The other ring, you got one of the nitrogens out here is providing a proton for the electron pair of the oxygen. The other nitrogen is involved with the bond. So those nitrogens are not just there for the heck of it. We'll do one gets brown. One H on the carbon gets brown. Methane gets the purple. If you want, electron pairs. So that's the thymine. Thymine is done now. One ring, 2 ends in it. Methyl side group, 2 ketones. Now to finish this ring off. Now remember, I was just saying this should have been an N, so I messed that up right off the bat. That's how simple that works. So nitrogen, that's the second nitrogen in that ring, and it's double bound there. So that third bond just goes to a carbon. That carbon goes double bound. That one. Double bond, color it in while we're here. So remember, all these rings got the two ends in them. So if you get lost on where you're going, so the little 5-membered ring on this, start with an N. This one here goes to an N. 1, 2, 3, 4. There's only one element in there, so you got to do a carbon in between them. And I should have drawn that around that way because it's going to be double bound to a carbon. So that's double bound. It's got to go single that way. So remember, I said they're held by the nitrogens, right? So down here, that nitrogen is off to the sugar. That was that one when we were talking about the angle of this. Got 1.11 nanometers across. Down here, you had an angle 51 degrees. So let's finish the rings off. I mean, we got 3 bonds. Those are done. You can draw the electron pair aliens in there if you want, just for the fun of it. But they're done, so you can color those in if you want. Should have that going all the way through, right? Because we want to show that that's part of the double bond there. So now you can easily go through and see the nitrogens that have the double bonds on them, nitrogens that have single bonds, nitrogens in the ring. See, no double bonds on those nitrogens up top. Then you come down here, all kinds of them. All right, what do we got? We got a diamond here. We can color that in. Got that one done. So no waste of bonding in these. Notice all these carbons here? These are Schroeder diamonds. They're all significant. Nitrogen, they're happy. Oh, we'll just do you all in blue, I guess, if you like to. Draw an electron pair in there if you want. So see, these are there, and they don't really play any role. But over here, Throw some yellow in there, shouldn't we, maybe? The alien mind meld. This is adenine. Sweet adenine. What do we got here? We got an H. It's brown, right? Now, due to the color coding, we're able to distinguish different carbons in these rings. I mean, come on, this is DNA, kids. This is adenine. It doesn't get any more fun than this. We look here and we wonder why that doesn't get a hydrogen bond. So next time I draw these, I'll try and do this triangle pointing that way, get this pointing so they're right on each other. This is okay. Try and angle those because that would be on the same plane because the distances is what we're focusing on right here. 2.90, 2.85. Oh, that actually is closer. Shouldn't have made that bigger. I should have made that one bigger. So the point is, though, that there's 2 bonds in there. The next one's going to have 3. All right, now we're going to compare these two, the cytosine and the guanine.